In this class, we are going to be looking at alkanoates, popularly called as esters. Esters found in fruits and this thing. So we are going to be identifying the functional group of alkanoates, then explain how alkanoates are formed, and write the IUPAC name of some alkanoates. Now, the functional group of alkanoates, functional group, is COO. This can be CH3. So we normally represent it like this: COOR. You know, R is alkyl. R is alkyl. So this methyl can be ethyl, it can be propyl, it can be butyl, depending on the type of compound. So the functional group of alkanoate consists of the carbonyl group, this carbonyl group, where the carbon is joined double bond to oxygen, it's carbonyl group. Then we have the COCO. So we have one carbonyl group, and two CO group, two CO. So this is one CO, this another CO. That's what we mean by two CO. This one CO, this another CO. And as I said, this alkyl group, this methyl, can be ethyl, it can be propyl, it can be butyl, depending on. Now, how are alkanoate esters formed? Alkanoates, this class is not to explore the laboratory preparation of it's not to explore we are not exploring the laboratory preparation of alkanoates in this class. So just for mentioning purpose, alkanoates are formed when an alkanol reacts with an alkanoic acid and is a reversible reaction catalyzed by an acid. When an alkanol reacts with alkanoic acid, then alkanoates are formed. Alkanoates are formed with water and is catalyzed with acid. So the type of alkanoates that are formed depends on the raw material. It depends on the type of alkanol you are using or the type of alkanoic acid that you are using. That will determine the type of alkanoates that are formed. For instance, when ethanol CH3CH2OH is reacting with ethanoic acid CH3COOH. This ethanoic acid and this ethanol, as I said, is a reversible reaction catalyzed by an acid. Now, what will happen is that the ethanoic acid, being an acid, will release hydrogen as hydrogen ion. You know, the definition of acid is a substance that will dissociate in solution to produce hydrogen ion in solution. So this hydrogen of this ethanoic acid is replaceable. It will be released. And when it's released, it will combine with this OH, the OH here, right? To form water. So your ethanoic acid will now remain as CH3CO. That is in the process of reaction, right? Like this, because this hydrogen has been removed. Now, the remaining part, this ethyl, since OH has combined with this hydrogen, this ethyl will now join to this oxygen here, making CH2CH3. This CH2CH3 is from our ethanol. This is the ethyl remaining because the OH has been removed. Then plus water. I told you that the hydrogen that is removed from the acid will combine with the hydroxyl of the ethanol to form water. So in naming this alkanoate now, You start because alkanoate is an alkyl derivative of alkanoic acid. Alkyl derivative of an alkanoic acid. That is, alkyl combining with alkanoic acid, replacing what the alkyl is replacing in the alkanoic acid is the hydrogen. Because after this, I will still give you 2 more examples. So now, in naming this alkanoate, you start from this alkyl. What is this alkyl? Ethyl. This is ethyl. Then the remaining part, this part, right? This is our alkanoate. So it's 2 carbon, 1, 2. So because it's 2 carbon alkanoate, it's called ethanoate. This is ethanoate. This is ethyl. So the name of this compound, you pronounce the alkyl first. The name of this compound now will be ethyl ethanoate. That's the name of this compound. Ethyl ethanoate. Ethyl ethanoate. Ethyl ethanoate. Now, let's look at another example. In a situation where you have propanol as a raw material, that's CH3, CH2, CH2, OH. This is propanol plus butanoic acid. This is CH3, CH2, CH2, COOH. Butanoic acid. This butanoic acid, 1, 2, 3, 4, is a 4 carbon acid, butanoic acid. Then this is 1, 2, 3, propanol. Propanol. As I said, the procedure is that this hydrogen, this butanoic acid will release this hydrogen. You know, as I said before, acid normally give out hydrogen ion in solid, will release hydrogen. And this ethanol will release OH. So they will combine together to form water. So your product now will be CH3, CH2, CH2, right? CO, you know, this from our butanoic acid. Butanoic acid, 1, 2, 3, 4. Now, remaining oxygen here. You know, I told you that the hydrogen has been removed. The hydrogen has been removed. So remaining only oxygen here. So this propyl now, you know, also here, the OH has been removed. I told that it is the OH here that combines with the hydrogen here to form water, So this propyl now will be joined to this oxygen that is left here. So you now have CH2, CH2, CH3, right? That is from this propanol. So this one is propyl. This is propyl because it's 3 carbon alkyl. Now, your alkanoate here is what? Your alkanoate here is what? How many carbon? 1, 2, 3, 4. So it's 4 carbon alkanoate. So this butanoate. This butanoate. So in naming this compound, as I said, we normally pronounce the alkyl before the alkanoate. So the name of this compound will be propyl butanoate. Propyl butanoate. That's the name of this compound. That's propyl butanoate. Propyl butanoate. Propyl butanoate. So the alkyl is pronounced first. So it's propyl butanoate. Let's look at another example. We have pentanol, CH3, CH2, 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 1, 2, 3, 4, 5. Plus ethanoic acid. CH3, COOH. It's a reversible reaction catalyzed by acid, as I said. Now, this is our acid. It will release hydrogen. Then the ethanol will release OH to form water. That's to form water. Now, this acid now, you write it. This is the acid. This ethanoic acid. This is what When the H has been removed, this is what will be left. Oh, now this 1, 2, 3, 4, 5. This is pentyl. This is pentanol. This is pentanol, our raw material. So when the OH is removed to join with hydrogen there to form water, what will be remaining is pentyl. So the pentyl now will join to this oxygen. So you have CH2, 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 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is pentyl, right? So this is pentyl, and our alkanoate here is what? Is 2 carbon. This is ethanoate. Because it's 2 carbon, ethanoate. This is our alkanoate here. Is 2 carbon, so it's ethanoate. So the name of this compound, as I said, the alkyl is pronounced first. So the name of this compound will be pentyl ethanoate. Pentyl ethanoate. So the type of product, the type of alkanoate that is formed is a function of the raw material that you are using, the type of alcohol, alkanol that you are using, or the type of alkanoic acid that you are looking at. So in this lab, we have been able to identify the functional group of alkanoates, and we also looked at how alkanoates are formed. I said it's just a reaction between alkanol and alkanoic acid, and is catalyzed by a mineral acid. That reaction is called esterification. But I said that in the purpose of this class, we are not exploring the laboratory preparation of alkanoate. We are principally looking at how it is named, and and I said that it is the reaction, it is the type of raw material that you are using that will determine the type of the product that is formed. So we have looked at various examples of alkanoates and how they are formed. So like this video, subscribe and turn the notification button so that when we upload more video, you will be duly notified.